When you're dealing with quadratic functions, any function that has the maximum value of exponent is a 2, you want to be able to have some ideas of how you might attack it, how you might find out information about it from just what they're given. So I'm going to go through an example and tell you some examples of what I mean. So in this case that we've given the function f of x is equal to ax squared plus kx minus 3, and it says where a and k are positive constants. And then which of the following is true of f of x. And then it gives us some choices about whether it's a maximum or a minimum value, and then in which quadrants. So what do we know when we're given this function? When anytime you're given some functions, there's some definite things that you can always try if you get stuck. So one of the things, here's the equation rewritten. As soon as you know that the a value in a quadratic, this is a quadratic, if you know that it's greater than 0, that means it's positive. So anytime that this is the leading coefficient there in this standard form, that a value. If a is positive, then you know that you're going to have a parabola that kind of opens up like this. And when they open up like this, that means they have a vertex down here, which is a minimum value. That's a min. If if a is a negative value, then you're going to have that inverted parabola, and then your vertex here is going to be a maximum. So when we go back at looking at these choices, we already know, because we know this has to be a positive value right there, we know that it has to be a minimum, so it can't be this one, and it can't be this one right off the bat. So now we have to decide whether it's a minimum value in quadrant 4 or quadrant 3. So another thing we want to do to test these is sometimes, don't forget when you can get intercepts. So an easy intercept to get is an x-intercept. Something like parabolas here, they're always going to have one and only one y-intercept. And the way you find that is, of course, you put in a 0, because when you're talking about some kind of graph here and any kind of parabola, when it crosses, wherever it crosses on the y-axis, the x-coordinate is 0. So how can I find it? Well, I'm not going to be able to find it exactly here, or can I? Watch what happens. The y-coordinate is, now I know that I have an a value, I don't know what it is, but my x-coordinate, I'm wondering when it is 0, what happens? Then we have the k here, and then I'm putting in a 0 for that x as well, and then I have the minus 3. So this is going to give me my y-intercept. It doesn't matter what a is. This is all going to cancel. It doesn't matter what k is. This is going to cancel to 0. So we know that the y-intercept is right there. It's a minus 3. So right now we know that 0, negative 3 is on that graph. So what do we know so far? We know that the graph, now it's just the y-intercept. It's not the vertex. I don't know whether I know that it has to come down here somewhere, that maybe it comes in, maybe goes like this, whatever, but the point is that I know that that graph exists below 0. If that graph exists below 0 and I am looking for the minimum value, it looks like this, that means that if this is a point below 0, but this isn't even the lowest, the vertex is down here or it could be over here, I know that the vertex, and therefore the minimum value of this graph, is below 0. I don't know right now whether it's in that third quadrant or the fourth quadrant. And here we have a choice between third and fourth. So I need to do a little bit more to this one. Remember that the vertex, the h value in these standard form, the vertex of hk, that is h value is always the opposite of b all over 2 times a. Well, for b, in this case, b is the k. So b is k in our little function here. And the a value that I have to do is actually also, it's called a there, in this one they gave us. So my vertex is going to be at negative b is really, since these is k, I'm going to have a negative of k all over 2a. Now, normally that might not help us, but keep in mind that we said that k and a are both positive constants. Right? So a and k are positive. So right here, if k is a positive number, but I have a minus in front of it, that means this comes out to be a negative sign up there. I don't care what the actual number is. I know it's a negative. And furthermore, I know down here when I do 2 times a, again, a is a positive constant. So that 2 times any positive number is going to be a positive. So notice this is going to come out to be a negative divided by positive. We know that the h value is some kind of negative number. It's a negative number. So again, then h is our x coordinate. All right, so we have some kind of, the vertex is at some kind of negative number for x. Well, which one, if I look at my quadrant here, I knew the vertex was down either in quadrant 3 or quadrant 4, but if the x value is negative for this, that means that, remember, the x values are negative to the left of the y-axis. So that means right away I figured out that has to be a -3 is where that vertex is and the minimum value. So using those techniques, I was able to find that it's in quadrant 3. Okay, so those are all very useful techniques when you're trying to, even when they don't give you real actual numbers, of figuring out what happens with these different A, B, and C values.